Start with the Animation Accelerator window. So Animation Accelerator is a secondary graphics window that we have added for NX, Creo, and SolidWorks. The main advantage of this window is to have an improved animation and deviation speed when we are working with larger models. It also supports rigid and compliant components by applying the deformation on parts. And finally, we have also added the color mapping functionality into this window. So on that note, let me switch into the CAD. So I'm using NX version 12 for this demo. This is a truck model, a quite large model with around 150 parts in it. To first launch the animation window, you have to come under the Update Model section. Under Model Navigator, hit the drop down and click on the Animation Accelerator. So once you launch the window right now in the background, what it does, it just goes through all the CAD parts in the model and try to convert it into HSR files. So once after conversion, it's going to save all those HSR files in the same folder where the model has been launched from. And also, depending on the size of the model, this conversion speed varies. So right now, let me just quickly auto scale so you can see the parts in the graphics. And this animation window is totally compatible with the ribbon as well as the model navigator. So now if I nominal build, so that's the nominal build speed for a large model like that. So let me try to put it in a better view. Here we go. And now if I do a quick deviation, so I can show you the deviation speed and zooming into a specific spot. So that's the deviation speed on this large model. So as I mentioned earlier, this is the main advantage of having this animation accelerator window, which drastically has improved any animation speed when compared to the native CAD. And as I said, it's totally compatible with the ribbon and model navigator. So I can show the points here. I can turn on the mesh so all that get displayed on the graphics. And similarly, if I come in here in the tree, I can click on a measure, for example, and that gets displayed in the graphics as well. So now quickly to talk about the other options that we have in the accelerator window. If I come to the bottom, there are a bunch of the first row of keys all are the graphic manipulation keys. And in addition to that, we also have the translucent checkbox, which will turn the parts on and off and put into its translucent state. Then we also added the color contour functionality to this window. So this function is basically similar to what we have in Multicad and CATIA V5. Now that we have implemented this through the animation window to NX, Creo, and SolidWorks as well. So I can just give you an overview of how this functionality works and how it has been integrated with the animation window. So first, to turn on the color contours, so you can either do it from the tree, like you can double click on a part and you can turn it on and off on individual parts from the edit part dialog, or you can do it from the MTM on off but dialog where you can turn this functionality on multiple parts or all parts at once. So once you have that done, prior, you can come in here, you can turn on this checkbox here, which will turn on the color contour in the window. So this is an additional dialog that we have added. So as I said, I have turned on the color mapping on only one part, but it's just giving you an additional option whether you wanted to turn it on other parts as well. So for now, I'm just going to say no. I'm going to stick with just one part for this demo. So as soon as you do that, you can see the part that you have activated the color contour on will turn into blue, and also a legend pops up here to display the deviation. So now I'm going to go ahead and quickly deviate. So now you can see the parts changing its color, and also the legend gets updated for the value of variation. So color contour is basically a visualization tool that shows the variation of the parts and assembly for the given deviation and also for simulation. It's a tool that helps the user to identify the critical part in their assembly process. So And that's the color contour deviation part. And now I have further more buttons in here. So let's get into the options. See, options dialog is where you can play around with the settings. Like if I want to change the position of my legend, I can drag and drop. So that gets changed. And I can change the font size. And also I can drag the color box up and down a little bit. So these are the legend settings. And if I comment down here, I have a couple settings for my simulation where, so as I said, you can run a simulation and the color mapping can also be done for the results. And based on this statistics selected here, those those uh, those values will be displayed on the screen. You can change around, like these are radio buttons where you can keep changing and play with the values. And on the right side, we have the color contour lines, which I'll be covering next. And also the deviation control, you can set the deviation direction based on the settings here. And that's about the color contour option. And then finally, I have the color contour lines. So to talk about the color contour lines, I need to run a quick simulation on this model. So let me nominal build and so once this completes, you can see few lines on the model. So let me this away. All right, so now if I zoom into this corner, so you can see a bunch of lines highlighted in the part. So these are the lines, and you can also see the values color coded for it. So now right now I have the legend displayed for the estimated range, and you can see there are different colors, and each color have a corresponding value. So now I can see a red line, and I see there is a 13.26 value of range for the red line here. And if I come back to my simulation window, and if I go through the estimator range column, I look for that 13.26. If I click that, you can see that measure gets highlighted in the graphics. So in this way, just by looking at those color coded lines, I can understand which is my larger estimator range value and which measures that and where is that measuring. So it's again coming back to the topic where I was saying this is just a visualization tool where it's just giving you a better understanding of both the simulation as well as the data.